All right, I'm going to go ahead and go over lesson 1.5. In this lesson, we're going to define and classify triangles and their related parts. The vocabulary will consist of right triangles, obtuse triangles, vertex angles, isosceles triangles, equilateral triangles, scalene triangle, acute triangle, base, and base angles. As a launch, in the diagrams below, which pairs of lines are perpendicular? Which pairs of lines are parallel? Which pairs of lines are congruent? Justify your answers with a few sentences. So in this figure here, I can see that line AB is parallel to line CD, and the reason is because of the arrow markings. These arrow markings indicate they're parallel. And then in this figure, I know that JM is perpendicular to JK. And that's because of this marking right there. And it says, okay, well, which pairs of triangles are congruent? And looking, it looks like SUT, triangle SUT is congruent to triangle, let's see here. So S corresponds to X, so X, and then U would correspond to Z, and then Y. There we go. So those triangles are congruent. Remember to go ahead and line up the letters. So you have 1 and 1. This has 3 markings and 3 markings. And that's 2 markings and 2 markings. Notice how all of the sides match up as well. Okay. You have learned to be careful with geometry definitions. It turns out that you also have to be careful with diagrams. When you look at a diagram, be careful not to assume too much from it. To assume something is to accept it as true without facts or proof. This is lightning, that is not lightning. Things you may assume. You may assume that lines are straight. If 2 lines intersect, they intersect at 1 point. You may assume that points on a line are collinear and that all points shown in the diagram are coplanar, unless planes are drawn to show that they are coplanar. Things you may not assume. You may not assume just because 2 lines or segments look parallel, they are parallel. They must be marked parallel. You may not assume that 2 lines are perpendicular just because they look perpendicular. They must be marked perpendicular. Pairs of angles, segments, or polygons are not necessarily congruent unless they are marked with information that tells you they must be congruent. Moral of the story is mark. Don't base things on how they look. All right, so we can assume lines are straight, 1 point intersection. You can assume that points on a line are collinear and that all points in a diagram are coplanar, unless planes are drawn to show that they're not. Remember not to assume. Careful not to assume these things. Parallel, perpendicular, and congruency. Don't assume those things unless it's marked. Okay. The diagram below. Oh, we just did this. Okay. Write a good definition of each bold-faced term. Discuss your definition with others in your group. Agree on a common set of definitions for your class and add them to your definition list. In your notebook, draw and label a figure to illustrate each definition. Here are right triangles. These are not right triangles. So we could say a right triangle has at least one 90-degree angle. So make sure to, in your notebook, draw and label the figure to illustrate each definition. Okay. Acute triangles, acute triangles. Acute triangles are triangles that have all angles less than 90 degrees. Okay. Obtuse with obtuse, we notice that each of these has at least one obtuse angle. But notice it's not obtuse if it's a right triangle. So obtuse triangles are triangles with one angle more than 90 degrees. Scalene triangles, here you can see clearly that scalene triangles are, let's see here, 8, 15. Here you have all of these are the same length. These are the same length. So it looks like all sides are different lengths. All sides are different lengths. Equilateral triangles, all sides are congruent. So all sides are congruent. Isosceles triangle. Looks like you have at least two congruent sides. So you can actually have all three sides congruent and it can still be isosceles. So you have to have at least two congruent sides. Isosceles triangle, an angle between the two sides of equal length is called a vertex angle. The side opposite the vertex angle is called the base, and the two angles opposite the two sides are called the base angles. So make sure this diagram goes in your notebook, as well as all of these definitions. Then you go ahead and complete this investigation, making a triangle. And there you go. Okay, cool.